Hello students, welcome to Prime Educare, a complete institute for JEE and NEET. So, in the previous lecture, we were studying about the significant figures, rounding of numbers and dimensions. So, we have gone through the various concepts in this chapter. So, now students, we will get into further concepts. So, we will learn about the vernier caliper and the screw gauge. So, we learned about the errors. We completed various other concepts like what are the types of errors we have. We have the systematic random errors. Then we talk about significant figures, then rounding of numbers. Now in this class, we are going to understand about the various measurement devices. So, for especially this is the very basic device in the class 11th, which is vernier caliper and screw gauge, which is also a very advanced type of experimental design. This is an advanced version where we measure using the vernier caliper. We measure the length and the diameter of a certain device. So, we have basically two types of instruments we have which we look into it. So, the first type of the instrument which we look into it is the vernier caliper, and the another type of instrument which we have is screw gauge. So students, what is vernier caliper? So vernier caliper is a device for accurate measurement. So why do we use this vernier caliper? For example, if we have the simple scale, it can read the value till 1 centimeter or 10 centimeter. So through a simple scale, we can measure the length 10 centimeter. But if we have to go into the but if we have to find more accurate digit, find the length to more accurate digit. So it will be like 10.1. If we have to measure to more accurate distance, if we have to measure the length to more accurate distance like 10.1, 10.12, 10.12, so we have to use a more precise devices. So what do we have to use? We have to use more precise devices. So more precise, more accurate devices which can give the value more accurately. So we have the vernier caliper. So in this is how the vernier caliper looks like. So this is how this vernier caliper looks like. So basically in the vernier caliper we have four types. So in the vernier caliper we have four types, and what are these four types are? We have the main scale, we have the vernier scale, we have the movable jaws and metallic strip. So we have basically four types. This is the main scale which looks similar to a normal scale. So this main scale, it looks similar to a normal scale which has a reading from 0 to 10. So this is the main scale which looks very much like a simple scale. So in this main scale we have a reading from 1 to 10. Then comes the vernier scale. So this is a vernier scale which helps in giving the value to more accurate value, which helps giving the answer to a more accurate value. So this is a vernier scale. Then we have the movable jaws, like we have this jaws are there. So these are the jaws A, B, C and D. So these are the jaws. And what do we have to, why do we have this jaws? This jaws measures the thickness, internal diameter and the length of the tube. So these are the jaws. And then we have this metallic strip. So this is the metallic strip where we can, like if we have a beaker, and now if we have to find the length of this beaker, so we can put this metallic strip into it. So we can put the metallic strip into it, and the metallic strip we can find the depth of it. So what we can find? We can find the depth of this cylinder. So through the metallic strip, we can find the depth of this cylinder. Okay, students, now we can go further. So, now we will describe about each of the type of the scale. So each of the type of the parts of this vernier caliper. So we have the main scale. So in this main scale we have a reading from 0 to 10. So in this main scale we have a reading from 0 to 10. So it consists of a steel metallic strip M, graduated in centimeter and millimeter. So we can read, it can be either we can read it either in the centimeter, we can read it either in millimeter, we can have the measurement in inches. So we can measure it centimeter, millimeter or inches. So we have the various type graduated in this main scale through which we can do the reading. Now let's come to another section where we have the vernier scale. So this is the vernier scale, and through which we have in the vernier scale we have the very small readings through which we measure the length. So in this vernier scale we measure the length through these small readings. Then again we will again describe it. These are the jaws, movable jaws in it. So these jaws are helpful in measuring, like if we have to measure the external diameter of a beaker. So this is a beaker, and if we have to measure the external diameter of the beaker. So if this is a beaker and if this we have to measure the external diameter, so we can measure it using these A and B jaws. And if we have to measure the internal diameter, so internal diameter can be measured using these C and D jaws. So these help in measuring the diameter of the beaker through A, B and C and D. Now we have a metallic strip, which I have already explained you before, that this metallic strip, it helps in measuring the depth. It helps in measuring the depth of a beaker. Like if we have a beaker, so if we have a beaker in it, we have a beaker, and if we have to measure the depth of it. So if we have a beaker and if we have to measure the depth of it, 1 minute. So if we have a beaker and if we have to measure the depth of it, so this depth of it, if we have to measure, then this depth can be measured using the metallic strip. Now, determination of least count. So how can we find the least count of this vernier scale? So students, what is the least count? So what is basically the concept of least count? It measures the smallest value. So what is the smallest value we can measure through any device? So if we have a device, we have a scale, we have a vernier caliper. So what is the minimum length through which it can measure? So what is the minimum length that can be measured? So what is the minimum length that can be measured? So that minimum length is called the least count. So that minimum length is called the least count. So students, in vernier caliper, what we have, the vernier caliper, if the end division of the vernier caliper, so let's say these are the end divisions, and these end divisions, it collides with the end dash division of the main scale. So basically, why do we have this vernier caliper? This vernier caliper helps to give the answer to 2 or 3 significant digits. Like if the answer is 12.1, and if we have the length 12 centimeter and one length is 12.1, then we can see a difference in it. So one is 12.10, 12.10, one is 12.12. So we can see a difference, like when we have the very precision experiments, when we have to perform experiments at a very macroscopic level, at a very microscopic level. If we have to perform the experiment at very microscopic level, we have to go till 2 or 3 digits. Because what happens in many devices, like if we have to find the diameter of a wire, then even a value with a 1 digit, even the value difference with a 1 digit can make a whole difference. If the value is having a very one, even a difference of 1 digit, it can make a very whole difference. So we have to give it very accurately and very precisely. We have to find these values. So students, now we have the concept of the least count. Like if we have the vernier caliper, and if we have to find the least count, so how can we find it? So let's suppose if we have the vernier caliper, and in this vernier caliper, if the end division of the vernier scale is more, will occupy larger space in the same division, because it gives its least count is lesser. So it will occupy a larger space as compared to the same number of division in the main scale. If we have the same number of division in the main scale, least count will occupy a larger value. So if let's consider we have the n number of divisions of the vernier scale. So for example, if we have the main scale, so let's consider if we have the main scale and this is the vernier caliper. Now if let's consider this is the vernier caliper, this is the main scale. So we have, this is the main scale and this is the vernier scale. So we have the main scale and this is the vernier scale. If the end divisions of this main scale, it's coinciding with end division of this vernier scale, main scale is coinciding with the end dash division of the vernier scale division. So what we can write it as that the end division of vernier scale is coinciding, let's suppose in this case what we have, like end division is coinciding with n minus 1. So but it can vary. We will see through the numerical that this value can vary. So if we have the n value of the vernier scale is coinciding, vernier scale has a larger divisions. So this is the vernier scale. So vernier scale has a larger division and this vernier scale division is coinciding with the end division of the main scale. So this vernier scale division is coinciding with the end division of the main scale. So end dash division. So n VSD has a larger number of division. In the vernier scale division, we have the larger number of divisions. So n divisions is coinciding with n minus 1 of main scale division. So n division of vernier scale division is coinciding with n minus 1 of main scale. Then what we can write, one vernier scale division equal to main scale division n minus 1 into n. And what is the least count? Least count of this vernier caliper. The least count of this vernier caliper is equal to main scale division minus vernier scale division. So the least count of this vernier caliper is main scale division minus VSD. So now we can put the value and this will give us the least count. So this will give us the least count, which is 1 by n MSD. So which is 1 by n of the main scale division. So this gives us the value of the least count. We will look more into detail through the numerical, like how can we find this least count. Now if we have to determine the zero error and zero correction, so through this example we can very much finally know how it is measuring it. So students, through this diagram, this let's suppose is the main scale. So this is our main scale. So this students is basically the main scale and this is the vernier scale. So we have a main scale and the other we have the vernier scale. So we have the two types of divisions. We have for one we have the main scale division and the vernier scale division. In the vernier scale division there are many marks into it. There are many marks. So we can see that through the main scale, through the main scale, so we can see that through the main scale, this division is coinciding with the vernier scale division. So this 10th division is coinciding here. So what we do, we take for the least count, we take, let's suppose we have the n division here, we have the n dash division here. So n dash n into this main scale is equal to n dash into vernier scale. So we find then the least count. So now let's talk about the because whenever we are measuring the length, whenever we have to measure the length of a device or whenever we have to measure the length of a cube, anything. So we have the two types of things we have. We have the one type of thing is least count and the other type of thing is the zero error. So least count that we have already discussed in the previous slide, like what is the least count. When the n division coincide, we how to find the least count. It is the least count is smaller than the main scale. Now in the zero error, how to see it, this is the main scale and this is the vernier scale. So the main scale 0 coinciding with the 0 of the vernier caliper. So here what we see that there is no error, there is no zero error, because the 0 of the main scale and 0 of the previous scale are at the same position. What we see that 0 of this main scale and 0 of the vernier caliper are at the same place. So what do we call it as? We will call that there is no zero error. In this case, zero error and zero correction both are nil, because both zeros are coinciding at the same place. The 0 of the main scale and 0 of the vernier caliper, they are at the same place. So what we see that there is no zero error. So the actual length will be equal to whatever the observed length. Now let's come into this another case. So we have this another case here. So in this another case, what we have is that we have this is the 0 of the first main scale and this is the vernier scale. So here we see that our vernier scale 0 division is not coinciding with the 0 of the main scale division. So here we can see that 0 of main scale is not coinciding with the 0 of vernier caliper. So in this case, there is a certain type of zero error. So what we can see that as the 0 of both devices means we have the main scale and we have the vernier scale. So the 0 of both these devices, main scale and vernier scale, are not at the same place. So what we see that it is coinciding with any main scale means it is not coinciding. So here we can see that there is a zero error. So zero error is there because the 0 of the main scale is not coinciding with the 0 of the vernier scale. So now how to find the zero error in this? So how can we find the zero error? So here in this case, the observed length will not be equal to the actual length. So how can we find the least count? Zero error. We will see that now which division is matching with the 1. So here we can see that this is 1, 2, 3, 4, 5. So this is a 0, 1, 2, 3, 4, 5. So the fifth division. So here we can see that starting from here, this is 1, 2, 3, 4, 5. Here we can see that the fifth division is coinciding with the main scale division. We can note that the fifth division is coinciding with the our main scale. So fifth division is coinciding with the main scale. So the least count will be equal to the zero error. Zero error will be equal to the value, means fifth scale is matching with the first one. So n plus nx, which number of division into the least count. So this gives the value that comes out to be equal to 0.05. So if the least count is 0.01, so least count is given 0.01. So this is the zero correction. So that means that whatever reading will be coming, whatever observed value, like we are calculating the observed length as 10.5 centimeter. So as the observed length is 10.5 centimeter, but here the vernier caliper has been shifted. But the vernier caliper has been shifted means vernier reading is greater. Vernier reading is greater. So that means that our observed value will be lesser than the actual length. So what we see, that the actual length will be 0.05, means whatever the zero error. So actual length will be 0.05 lesser than the our observed value. So this is what will happen. Now 0 of the vernier scale lies left, 0 of the main scale. Now if the 0 is lying before it, so in this before it, that means here the least count, here the zero error is in negative. So here the zero error in negative. So we will again calculate the zero error using the same method. We will again find the zero error using the same method, like which we have the fifth reading. We have the fifth reading coinciding with the fifth division. So we have the fifth reading coinciding with the fifth division. So similarly we can find the least count, zero error. We can find the zero error. So this is negative, like how far it is. It is -1 plus 5 into fifth division is coinciding with 0.01. So this gives the value. Okay, so now here in this case the actual length will be 0.05 times greater than the real value. So students, what we understand the concept of, we have gone through the concept of first the zero error. So zero error in the case of vernier scale, like when when we are reading the number of division coinciding, when we are reading the number of division coinciding, so what we do in the vernier scale, we take, for example, this is our vernier scale, so vernier caliper. So in this vernier caliper, where we are finding our zero error, how we are finding the zero error? So this is the main scale, this is what we have. So we will bring this vernier caliper, so we will bring this vernier caliper at 0th position. So we will bring the vernier caliper at 0 position and then we will compare it. So we will bring this vernier caliper at 0 position and then we will compare it. Like, is the 0 coinciding with the 0 of the vernier caliper? Is the 0 coinciding with the 0 of the vernier caliper? Is it away or is it back? Is it far or is it back? Then we will compare it, like how will be the observed value? Is the zero error negative or positive? So this zero error we calculate at the initial level. So this zero error, what we do, we calculate it at the initial level. When we are seeing the instrument, we are not using any device. What we are doing, we have the main scale and we bring this vernier caliper at the 0th position. So we bring the vernier caliper at the 0th position and then we compare, like whether the 0 mark is coinciding with the 0 of this vernier caliper or not. We then compare that 0 of the main scale is coming aligned with the 0 of the vernier caliper or not, and then through that we find the zero error. So if the 0 is coming at the 0th position, then we say that there is no zero error. If it is coming again, it is coming, means if the vernier caliper is shifted to the right, if the vernier caliper is shifted to the right, then we say that the zero error is positive, so the actual length will be lesser. So actual length will be lesser than the observed value if the 1 year scale division is left to it. So 1 year scale division is left to it, then we say that the zero error will be negative. That means our actual length will be greater than the observed value. Now students, when we are performing an experiment, so performing an experiment is a very delicate task. So performing an experiment is a very delicate task where we have to take various instruments very precisely, where we have to perform each experiment very precisely. So we have to take certain types of precautions to it. So what are these types of precautions to it which we have to consider? So in the precautions, we have to consider that motion of the vernier scale or main scale should be smooth. It's not like that when we have the instrument and when we have the device. So when we have the device, so let's consider this is the device and we have the instrument. So when we have the instrument, like these are the jaws, so they are measuring the length accurately. So they are measuring and very delicately we are placing it, because if we do it in a hurry, if we do in also not in an accurate way, then the answer can be come out to be different. Then vernier constant and zero error should be carefully found. So when we are performing the experiment, we should know like what is the least count in it, what is the value of the least count, what is the vernier constant in it. Then the body should be gripped between the jaws firmly. So if we have these jaws should be uniformly clipped between this beaker. So it should be uniformly clipped because it should not move away. Observation should be taken at right angle. We should take, because there can be the case of the parallax error. So what can happen that we can suffer through the parallax error. So we should see the objects very accurately. We should see and we should very focusedly see the objects that they are placed at right angles. Else there can be the case of the parallax error. So now students, these all about the vernier caliper. So we have gone through the least count, we have gone through the zero error, we have gone through the precautions that has to be considered while performing the experiment. Now we will see like what is the sources of error. So what are the sources of error that should be considered? The vernier scale may be loose. So what can happen that our vernier scale through which we are measuring this device, it may be loose. The vernier scale may be loose because that may be the case that we have not properly taught it. So it can be the case. The jaws may not be at right angle. What can happen that the jaws which we have, they are at not at right angles. Then the graduation may not be correct. There can be the case that the instrument might be overused, so the divisions on it might be removed, they might be cleared off, and the parallax there, so there can be the case of the parallax error. So these are the errors which can happen while we are performing the experiment. So these can be the cases of the errors which can occur while performing the experiment. So these also which we have to keep in mind apart from the precautions. Okay students, so we have gone through our first device, that is the vernier caliper. Like why vernier caliper is using to give more accurate answers, to measure more accurate division, accurate length, to accurate length, diameter or the depth, to measure it more accurately. Now we will go on through this numerical and we will understand it more in detail, like how is this vernier caliper help in measuring the values. So students, let's go in. So what we have the vernier caliper and it has a main scale. So we are talking about the main scale. So in the vernier caliper we have the main scale. So in the main scale we have the length of the 10 centimeter and we have the 200 divisions. So if we understand it, so we have basically 200 divisions. So in the main scale we have 200 divisions. So in the main scale we have 200 divisions, and these 200 divisions are measuring a length of 10 centimeter. So these 200 divisions, they are measuring the length of 10 centimeter, and it's 1 year scale of 25 division. Then we have the 1 year scale 25 divisions, and it is coinciding with 12 meter of the main scale. So 12 millimeter of the main scale it is coinciding with. So which is the 12 millimeter, or which is the number of division of the 12 millimeter? So we can find it out, and then we can find the least count. So students, what is basically the least count? So if we understand it, so what is basically the least count? Least count is main scale division minus 1 year scale division. So if we understand it, least count is 1 main scale division minus 1 year scale division. So we have the least count, which is 1 main scale division minus 1 year scale division. So we have the main scale division, but now we have to find what is the 1 year scale division. So 10 centimeter we have the 200 divisions. So that means, like, where will be the 12 millimeter? 12 millimeter is 1.2 centimeter. So 12 millimeter, if we are measuring the length, 12 millimeter length is measured. So 12 millimeter length means we are measuring 1.2 centimeter, because 12 millimeter is 12 divided by 10, which is 1.2 centimeter. So we have, so for 1 centimeter the number of division will be 200 divided by 10, which is equal to 20. So for 1 centimeter we are covering how many divisions? 20 divisions. So for 1 centimeter we are covering 20 divisions. Yes or no, students? So for 1 division, 1 centimeter we are covering 20 centimeters. Now for 1.2. So for 1 centimeter we are covering 20 divisions. For 1.2 centimeter it is equal to 1.2 into 20. This will get cancelled. This comes out to be 24. So that means for 1 centimeter we are covering 20 divisions. So for 1.2 centimeter we are covering 24 divisions. So for 1.2 centimeter we are covering how many divisions? 24. So that means 25 of the main scale division. So we have 25 of the main scale division is equal to the 24 of the 1 year scale division. So 25 of the main scale division is equal to the 24 of 1 year scale division. So from here we can know that what is the 1 year scale division is equal to. So the 1 year scale division is equal to 25 by 24. So this is equal to, so 25 of the main division, it is coinciding with 24 of, it coincides with the 12 millimeter of the main scale, sorry, 25 division of the 1 year scale. So we have the 25 division of the 1 year scale. So we have the 25 division of the 1 year scale. It is coinciding with the 25 of the main scale. So 25 of the 1 year scale is coinciding with the 24 of the main scale. So 1 year scale division is equal to 24 by 25 main scale division. So now from here we can find the least count. So students, what is our least count is equal to? 1 main scale division minus 1 main scale division minus 1 year scale division. So that is equal to 1 minus, what is the 1 vernier scale division value is equal to? So this is the least count. So what is the least count? It is the, so least count is 1 mean scale division minus 1 vernier scale division. So 1 MSD minus 1 vernier scale division means 24 by 25. So this is equal to 24 by 25. So what we can write it down? So we can write it down that least count is equal to 1 MSD minus 24 by 25 MSD. So this is equal to 1 by 25 of the main scale division. So this is the vernier scale division. So this is our vernier scale division. So that means 1 vernier scale division is equal to 1 by 25 of the main scale division. Now if we have to find, so this is the least count. So now we have to find the least count. So least count is equal to 1 by 25 into main scale reading. So 1 by 25 into what is the value of the 1 division in the main count? So we have for 10 centimeter we have 200. So for 1 division the value will be equal to 10 upon 200. So for 1 division we have the value of 10 upon 200. So this will be cancelled. So it is equal to 1 by 20. So we can write it as 1 by 20. So this is how we can find the least count. Now students, we will go further. We will have the next device which is called the screw gauge. So students, what is the screw gauge use? Screw gauge is basically used to find the thickness. So screw gauge is basically used to find the thickness and it helps in giving the more accurate. It gives the answers to a more accurate level. So the screw gauge gives the answers to a more accurate level. So we have a screw gauge which is a precision measuring device which is used to measure the thickness of the small objects. When we have the objects which are very small thickness, which have a very small thickness, there we use a screw gauge and it gives the value with high accuracy. So now main scale, so we in this screw gauge, so what do we have in this screw gauge? In this screw gauge we have the main scale, vernier scale and thimble. Similarly we have the main scale and then we have, this is the rotating device which measures the value using vernier scale. And then we have a thimble here which is a rotating part which covers the number of revolutions, number of rotations which we have. Now, so what is the advantage of screw gauge? So we already have the vernier caliper, but why we are using screw gauge? We already have the vernier caliper. Why are we using screw gauge? So screw gauge helps in giving the thickness. So screw gauge helps basically in giving the thickness of the device. So basically we are measuring the thickness of a pen, thickness of a rod. So this basically helps in measuring it. So this is the image of the screw gauge, how it appears, how it looks like. So through the rod we put here, we put the rod here between these screw gauges and then measure the length. So it is high accuracy. It is high accuracy. It can measure the thickness to the nearest hundredth of a millimeter. Can be used to measure the wide range of objects and relatively small and easy to carry. We can easily carry it. What is the disadvantage of the screw gauge? Why we don't, what is the disadvantage of it? So it requires careful handling. What happens that this is a very sensitive device. So when we are rotating using a thimble, So what can happen? It can disrupture it. It can disrupture it. So this requires careful handling. Limited range may not be suitable for very high thickness. It will happen that it may not be suitable for very high thickness and very thinness. Now, determination of the least count. So how can we find the least count of this screw gauge? So what is the method to find the least count? So we have basically the two denotions here. We have basically the least, first we have the pitch. We have the first denotion, that is the pitch, and then we have the least count. So we have the two denotions, we have the pitch and we have the least count. So what is pitch? Pitch is distance moved in one rotation, like how much length it is covering upon the total number of full rotations, like whatever the length is covered, and what is the length covered in one rotation. So what is basically is pitch is what is the length covered in one rotation, that gives the value of pitch. And then the least count, it is the pitch divided by number of divisions, the total number of rotations, total number of length that is covered in one divided by number of divisions, which gives the value of the least count, the minimum distance length which it can measure. So what it is, the least count? It is the minimum distance which it can measure. So in basically in the screw gauge, we have the two basic concepts. So in the screw gauge, we have the two basic concepts. We have the concept of the least count and the concept of pitch. So pitch gives the length traversed in one rotation, and least count measures the least distance it can measure the length. Then determination of zero error and zero correction. Similarly, just like in the concept of the vernier caliper, how the zeros are coinciding with the zero of the main scale, then we find whether there is a zero error or not. Similarly, what we do it in the screw gauge also. The screw is rotated forward till plane of this face of the first plane is coinciding with the face of the second plane. Now, we can see here in the similarly that here the zero of this vernier scale. So basically we have the two scale, we have the vernier scale and the main scale. So zero is coinciding with the zero of the main scale. So we say that there is no zero error. Here we can see that this is the zero is here, but the main scale, this vernier scale is coinciding with the second division. So the vernier scale is coinciding with the second division, and the zero of the main scale has already moved. So actual thickness, whatever the actual thickness will come, it will be lesser, it will be larger than the observed. Here we can see that the zero of the main scale is here, and this is the zero of the vernier scale. So it has moved further, it has moved greater. So here it will be, the value will be more than the actual value. It has already moved in, it is the zero of the main scale, vernier scale is coinciding with the third division. So it is moving. So while measuring, again in this we have to take the certain types of precautions. So what are the certain types of precautions which we have to take? We have, while taking an observation, screw must be turned and it has to be very much tightly placed. And we take reading in pairs, we have to take multiple readings. It cannot happen that we can take only one reading. We have to take many readings. Then the wire must be straight. Always rotate the screw in one direction, else there can be the case of the backlash error when we are rotating in the forward and then we are rotating in the backward. Rotate the screw in one direction only. So what are the sources of error here also? Okay students, now we will talk about the sources of errors. So in this screw gauge, we have gone through the precautions, we have gone through, now we have gone through the sources of error. So what is the sources of error? The screw may have friction. There can be a case that these screws have the friction. Then it can have the backlash error. What is the backlash error? When the error, when we are rotating the thimble, so it can be happen that the thimble is rotated in both direction, in the clockwise direction or in the anti-clockwise direction, and circular divisions may not be of equal size. There can be the case when the divisions are not accurate. This can have the x1 distance, this can have the larger distance. So this can happen in the source, in the, when we are measuring the length. Now students, we will look into the numerical. So what is a numerical? In 4 complete rotation, the distance travelled on the pitch scale is 2 millimeter. If there are 50 division on the circular scale, then what is the pitch? So now students, we will understand the numerical. So what we have? We have the pitch. What is the pitch? What is basically the pitch? Pitch is the total length covered. Pitch is the total distance covered upon the number of division. So pitch is the total distance, what total distance we are covering upon the number of division. So in 4 complete rotation, the number of division distance travelled is 2 millimeter. So if the distance travelled is 2 millimeter, then this 2 millimeter distance travelled is in how many rotation? 4. So 2 millimeter, it is equal to 2 into 10 to the power minus 1 if we have to give the answer in centimeter. So this will get cancelled and this comes out to be 0.05 centimeter. So what is pitch? Pitch is basically the total distance covered in one revolution. When we are covering a one rotation, like what is the total distance covered? So that is equal to the total distance covered in n revolutions. So this is 2 upon the number of revolutions are 4. So this gives a value of 0.05 centimeter. Then what is the least count? So the least count is very much simple. Least count will be equal to the total distance covered upon the number of divisions, which is equal to 0.05 upon 50. So this will get cancelled. So least count is 0.05 upon 50. This is 100. This is 10. So this gives the value of 0.001 centimeter. So this is our least count. Now students, let's go further. So in this numerical, what it is given? The pitch of a screw gauge. So the pitch of a screw gauge is given. So we have the pitch of a screw gauge, which is equal to 0.5 millimeter. So pitch of a screw gauge is equal to 0.5 millimeter and there are 50 divisions on the circular scale. So we have the 50 divisions on the circular scale. In measuring the thickness of a metal plate, there are 5 division on the pitch scale and 34 division coincides with the reference line. Then we have to find the thickness. So what is the thickness is equal to main scale division, main scale reading. So we have the main scale reading. So thickness is equal to the main scale reading plus the least count, number of divisions into the vernier scale. Number of division into vernier scale reading. So now if we say that, first of all, if we see that the 34 divisions coincides with the reference line. So this is 34 divisions coincides with the reference line. So 34 division, that means the least count will be, least count is equal to of the vernier caliper is, if we have the pitch is 0.5 millimeter, 50 divisions are there. So 0.5 is the pitch, 50 divisions are there. So that comes out to be equal to, this will get cancelled, this is 10. So this is equal to 1 upon 100. So which is equal to 0.01. So this is equal to 0.01. Then there are 5 divisions. So this is about the vernier scale reading. So vernier scale reading means 34 division into the vernier scale. There are 5 division on the pitch scale and of the main scale. So 5 division on the pitch scale. So 5 division into the least count. So this is equal to 5 into the least count of the main scale. So the least count the thickness of the on the pitch scale. So this is this gives the value of 0.5. So 5 into 0.5. So this will gives us the value of the thickness of the rod. Now we will go further. Okay students. हाँ वो हो गया रिकॉर्डिंग. हाँ हो गई रिकॉर्डिंग. हाँ हाँ वो मेरे ख्याल से वो बोलने कट करना पड़ेगा वो क्योंकि वो हो रहा था इसमें लास्ट